All right, y'all. So, what I'm gonna do is I'm gonna go over example number 6 real quick on this. So, what you want to do first is just sketch out a diagram of what we have right here. So, you got this function e to the negative 2x. So, I'm just drawing a rough sketch of that right there. All right. So now we got that. So, what we want to do is we want to think about the area that the area that we want to rotate, right? So, we're going to rotate all this stuff is bounded by 0 all the way to infinity. So we're talking about to get to the very, 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 very end of that curve right there. So that's just going to keep going. All right, we want to rotate this around the x-axis. So then it's going to be this. And remember, we still have this where if we rotate this around the x-axis, we're going to have our representative slice that looks like this. Remember, the radius still goes from the center of the rotation to the function. So the r is just simply going to be e to the negative 2x. There's going to be that perpendicular method right there because the cross section is perpendicular to the axis of rotation that we have. So for this will be a pretty straightforward one. It's just that we got this little wrinkle of the improper integral that we're going to have to deal with momentarily. But you got this. You got the volume is equal to, you got pi times the integral from 0 to infinity of e to the negative 2x. You're going to square that and you're going to integrate that in terms of x still. So now what we have to do is we have to account for this problem in the boundary right here, trying to integrate to infinity. So that's why we change this to a limit. So now it's going to change. So now this is going to become, we got that the volume is equal to, going to be the limit as b approaches infinity, 0 to b, e to negative 4x dx right here. All right, so now all we do is we need to find the anti. Whoops, sorry, I forgot my pi right there. Sorry about that. All right, so now we got this. So we want to find the antiderivative of this now. So we still know that this volume right here is going to be equal to, you got the limit as b approaches infinity of pi times negative 1/4, and that's going to be times e to the negative 4x, and we're going to evaluate that from b to 0. Alright, so now what I'm going to do is I'm going to clean this up a little bit, but I'm also simplify things a little. Alright, so when you find this, when you evaluate this function, you remember we need to use the fundamental theorem of calculus. So we still need to apply this limit, but we're not going to apply that limit until the end. So we got the limit as b approaches infinity. We need to sub in b to this function. So what I'm going to do is I'm going to pull out all of my constants, which are just going to be negative pi over 4. And then if I evaluate this at b, it's going to be e to the negative 4b. And then it's going to be minus. And then if I evaluate e to the negative 4x at 0, that's just going to become 1, because anything to the 0 power is just going to be 1. Now what I do is I apply this limit right here now. So I take this limit, negative as b approaches negative infinity to b. Since that's a negative exponent, you know that that's going to be 1 over e to some big crazy power. So then that thing's going to go to 0. So really all you'll be left with is negative pi over 4 times negative 1, which is going to be positive pi over 4. And then that's it. That's all. All right. If this is still like cloudy or hazy for some of y'all, then just let me know what's up. All right. And I'll talk to y'all Thursday if nothing else.